Uh, I think most of you already learned about this because this is basic, but we just go through again. I'm not sure whether you all aware or not. While aircraft flying, not only one system. I mean, when aircraft want to roll or do the any movement, usually not only one flight control are using. Let's say when aircraft want to do roll, not only the aircraft using aileron, but it will also need to be assisted by spoiler, and also need to be adjusted the rotation by the rudder. So in the conventional, it is quite complicated because of the mechanical linkage. So by using a fly-by-wire, this one, the movement by several flight controls at the same time can be done only by the actions of the computer. So the computer will tell which flight control to move and which at what angle. Okay, this is the basic flight control system which using control cable. So input from the cockpit, either by control wheels or control columns, will link to the mechanical linkage. So there will be a set of control cable. The maybe if let's say the control surface for elevator and rudder, so the whole fuselage there will be a linkage for the control cable. Then the control cable will be connected to a push-pull rod and will actuate the valve on the actuator, and this will allow hydraulic to come in and to move the control surface. The mechanical linkage also can get input from the autopilot. So there are two commands here, either by a control columns or by the autopilot. If students have any question, can ask. If there's any that you want to ask or any information that you want to clarify, you can ask. Okay, this is a sample of the flight control system on ATR 42 and 72. As I said just now, the mechanical linkage like this one is for the elevator. So the control cable will go throughout the fuselage to the tail sections. So imagine how long is the cable and how much the weight, unnecessary weight. And if all this linkage can be replaced by a cable, so it will save a lot in terms of fuel economical. It will increase.
What is the material for the cable?
It's a steel. There are different type of the material, but most of them use CRS, corrosion resistant steel. We go back to the previous slide. Okay, so this is the ATR aircraft, and the cable that I showed you just now run from the cockpit here, go to the underfloor here, and at the back it will come to the ceiling panel and run through all the way up to until the tail, and then from here it will change the directions using a push-pull rod and goes to the elevator here. So for the maintenance side also, there's a lot of maintenance because we as an engineer and also a group of technicians will have to inspect all the cables because of the cable is moving in flight. So there will be a wear and tear. So we have during the hanger check, we have to open all the ceiling panel and inspect all the cables, all the pulleys, bell crank. So there's a lot of job, and we also have to check the tensioning of the cable. In the in this slide, I show you that there's also autopilot input. So for at here, we can see there's a autopilot pitch actuator link on the cable, link on the mechanism. It give input here. So the cable, the input can be from control columns or control wheel, goes all the way to the elevator, and at the same time, the autopilot computer also can give input here and move the control surface. Okay, clear? Okay, this one is also a conventional type of flight control system, which also using cable. Like I said the early just now, I said in flight not only one flight control is working. It can be combined with the spoiler or rather, and in this case, 737 flight control system, the aileron, the connections of the cables is linkage with the flight spoiler. So here from the input from the cockpit, there are two sides of control cables go to under the floor of the cabin floorboard to the wheel well. Here, it will connect it with the spoiler mixer. So the movement of the aileron, the movement of the control wheels, instead of move the aileron, it will also move the flight spoiler. So flight spoiler will assist the aileron while doing the roll actions. So you can imagine how the complicated of the linkage. To so many of controllable. So for this one, for the engineer and also for the tensions, the job is quite tough because sometimes there's a wear and tear, especially the cables at the behind here, because this one is exposed to the moisture. It is located behind the wing butt head, wing rear spar, and it's exposed to the moisture and vibrations. So there's many tasks need to be done here.
How you detect the tear or maybe a stress or maybe a structural damage to the cable?
Okay,
how you detect?
Usually we are using visual inspections, and at some area maybe we will need like using the wax or cloth, because this one is combined of strands of wire. So maybe inside the strands, maybe one or two wires is broken. So we need to refer to the maintenance manual, the limit. So the inspection is by running the dry cloth along the cables, throughout the cables, and also by visual inspections. So the most common is the pulley. sometimes it will because it's keep moving in flight. So there's a lot of wear and tear here. Another inspection that we need to do is a cable tension check. It's very important to ensure the cables is at the correct tensions all the time, because if it's too loose, the pilot when move the control cable, the flight control will act sluggish. It will not move freely, or it will not move to the angle that the pilot or the computer want. Wait, okay, so that's a conventional control cable. So modern aircraft now change to fly-by-wire system. So what is the fly-by-wire system? It's a semi-automatic computer-regulated aircraft flight system, flight control system. Why it's called semi-automatic? Because this system is not involved with the autopilot yet. If the autopilot come into the system, then it will become the automatic. The autopilot is a separate system. So the example of the fly-by-wire aircraft that commercial aircraft that using fly-by-wire system now is A320. A320 is the first commercial aircraft that utilize this system, starting 1980 something, I think. Then the other models that Airbus produce all using the same fly-by-wire system. Even most of their system is taken from the A320. It's most the same, only slight change for the most modern aircraft like A380 and A350. And Boeing only start using the fly-by-wire system on their 777, and now the latest aircraft 787. Even their 737 also not use the fly-by-wire system. Okay, this how's the basic diagram of fly-by-wire system. So the input from the cockpit can be either by side stick, which was used on Airbus, or by the control column and control wheels on the 777. So input from the cockpit to the flight control computer all by wire. So there's no more control cable. Flight control computer also can get input from the autopilot. Then from the flight control computer, it will compute all the input from autopilot or side stick, and it will check whether it is in their limit, which is in their flight protection envelope, which here is called law. If it's within limit, then it will direct the signal to the actuator, or the actuator valve, hydraulic valve on the actuator, all by using cable. So instead by using a complicated arrangement of flight control cable, it can utilize only few wires. So there's a lot of weight saving here. Then after the control surface move, it will send back a signal to the flight control computer. And so there's a various sensor like pitot-static, all can give input to the flight control computer. So all this done by electronically, no more cables. So from the maintenance, from the maintenance is a lot of help because it less our task on the aircraft.
Can you explain more about the actuator feedback? You mean there is a sensor somewhere in the actuator, or
Yes, there's a sensor. There's a transmitter here. Will transmit. It will measure the movement of the control surface and then give back signal to the flight control computer. Every control surface have a sensor which measure the movement of the control surface. So in case the movement, the flight control computer still not receive the amount of deflection that the flight control computer asks, when it detect the so it will give back the order to move to the directions. Okay, this example of the fly-by-wire system in the A320. Ada aircraft like ada Airbus aircraft like A330, A340, almost the same, but maybe the numbers of computer is different and the name is different, but the design wise is like this. In the flight control system, the one big problem that this system have is a redundancy. If it using one computer, let's say the computer fail, it will give a catastrophic incident to the aircraft. So what they do is there are several computers on the system. One is active and one will be as a backup. In case failure of the one computer, the other computer will take over. So all the computers have two, and this one have three. So the input from the pilot, let's say by using a side stick, it will give input to this one. This computer is control aileron and elevator. Let's say the aircraft want to do a roll actions, it will also give a signal to the FAC computer. This one control the yawing of the aircraft. So it will also give an input to the rudder. So all this done, all the integrations or the flight control is done by electrically, no mechanical input. So in this system, it's easier to integrate several flight control surface movements compared to the conventional system. But some of the system are still using still have mechanical backup, like this one rudder. rudder can be operated by electrical or also by a control pedal. There's also still have a linkage, mechanical linkage to rudder for a backup. Seems like the trim horizontal stabilizer, they can be moved by using electrical input, and also there's a backup by a trim wheels to the trim horizontal stabilizer. This is I can say for the A320, for the flight by wire system, the A320 system is quite simple. If you I have a chance to learn on the other aircraft like the 777s, it's more complicated. But this one is I think is the simplest fly by wire system. There are several computers and all of them are talking each other with each other. So all the movements can be done simultaneously. Let's say pilot want to move the allowance, the elect computer also will give a signal to the spoiler, or from the side stick also can goes directly to the spoiler computer and give a signal to the flight spoiler control surface. So on the computer, we will give and get other input from various aircraft sensor like accelerometer, LGCIU, radio altimeter. It will compute within the computer. Okay, so this one is
Mr. Sharizal, can you explain more about the computer? Because we are thinking that this computer, like a conventional computer that we have like desktop now. So can you, I think, illustrate or macam mana macam gambarkan, picturize how that computer exactly looks like. Like UAV is they only use Raspberry Pi as a computer. But now for the fly-by-wire system, how is it? It looks like a computer to control this fly-by-wire.
actually it's not like normal computer. It's just like a board which consists of several circuits which control the logics inside that, and all the motherboards have was put in the one box, and that box we call a computer. So the computer we cannot interrogate much, only by using a byte test. I can say that it's more like a desktop CPU, which consists of several board inside it. And inside the computer also have several channel. So in case one board is fail, it does not mean that the whole example is like computer is fail. Maybe only one channel. Okay, Dr. Nazri.
Okay, understand.
Okay, thank you. Okay, okay, this is summarize of the A320 flight control surface. So most of the flight controls all are using electrical. Elevator, aileron, spoiler, speed brakes, and for stabilizer and rudder, there's a electrical, and also at the same time there's a mechanical for backup. And all the flight control surfaces are operated or actuated by a hydraulic. So, in case of you, maybe some of you not understand or cannot imagine how the arrangements. So I prepare one video I take from YouTube. I think this one quite easy to understand. So I will show you the video.
In this lesson, we will examine the flyby.
Boleh dengar Dr. Nazri?
Boleh.
Okay.
Wire flight control systems in use on many of the most modern large aircraft. Mechanical and hydromechanical flight control systems are heavy and require careful routing of flight control cables through the aircraft using a system of pulleys and cranks. They also require a lot of maintenance in the form of lubrication, tension adjustments, and so forth. These systems have a very limited ability to prevent dangerous characteristics such as stalling or spinning. Electronically controlled flight controls in systems known as fly-by-wire systems overcome many of these problems. By using electrical control circuits combined with computers, designers can save weight, improve reliability, and use the computers to prevent undesirable aerodynamic characteristics. Between the pilot and the final control actuator, a computer system is interposed. This modifies the pilot's inputs in accordance with carefully developed and validated software programs in order to produce maximum operational effect without compromising safety. The pilot's commands are converted to electronic signals. These signals are passed to the flight control computers, which determine how best to move the actuators at each control surface to provide the desired response. The actuators are still usually hydraulically operated. The computer monitors the aircraft's response to the flight control movement and modifies its output to the powered flight control unit as required. All Airbus aircraft since the A320 series have used fly-by-wire controls. Boeing have followed with their 777 and later designs. Side sticks, or conventional control yokes or wheels, are used in fly-by-wire aircraft. The side stick offers the advantages of being lighter, mechanically simpler, and unobtrusive. Standard rudder pedals are used. Boeing consider the lack of visual feedback from the side stick a problem, and so use conventional yokes in their fly-by-wire designs. The Airbus series have used side sticks extensively, and the new Airbus A380 uses them. The main concern with fly-by-wire systems is reliability. While traditional mechanical or hydraulic control systems usually fail gradually, the loss of a flight control computer could immediately render the aircraft uncontrollable. For this reason, fly-by-wire systems incorporate either multiple redundant computers, some kind of mechanical or hydraulic backup, or a combination of both. The Airbus A320 fly-by-wire system is a fairly typical system, so we will now take a look at its features. There are 7 computers and 3 hydraulic systems looking after the primary flight controls. Each primary flight control has 2 hydraulic actuators, each fed from one of 3 independent hydraulic systems. There are 2 elevator aileron computers, or ELACs. These control the elevators, ailerons, and stabilizer. Only one of these computers is controlling at any time. The other is a backup and will automatically take over in the case of a failure. There are 3 spoiler elevator computers, SECs. They control the spoilers. And in the event of failure of both elevator aileron computers, they will also control the elevators and stabilizer. Although the pilot controls the rudder through a conventional hydromechanical system, there are also 2 flight augmentation computers, FACs, which operate the rudder to automatically give roll assistance. The stabilizer trim is hydraulically operated. It can be mechanically controlled by the pilot's trim control wheel. This system has both electrical and hydraulic redundancy built into it. The elevator and ailerons have access to up to 5 computers, only one of which is needed for them to operate. The aircraft has 3 hydraulic systems. Each control surface can be operated by either one or 2 of these systems. Even if 2 of the hydraulic systems fail, the aircraft will still be controllable. In the event of a total electrical failure, the aircraft can be controlled longitudinally with the trim wheel and laterally with the rudder pedals, both of which operate their control surfaces hydromechanically. To summarize fly-by-wire systems, they are lighter than conventional systems, and they improve the control of the aircraft throughout the flight envelope. As with conventional systems, they have a great deal of redundancy built into them.
As aircraft have become larger and faster,
Okay, there's a short videos of the taken from YouTube. Go back to the presentations. So some of the advantage have been explained in the video just now. So the advantage, one of the advantages is there's a flight envelope protection software that is in the system. So it will limit the aircraft movements to prevent the unsafe actions. That means there's a maximum and minimum limits in the computer, so that let's say the aircraft turns the side sticks or the control wheels too much angle, but the computer will there's in the safety protections inside the computer will limit the movements, so pilot cannot do something that unsafe. In this system also, the turbulence suppressions and is increased. The turbulence suppression and consequent decrease of fatigue loads for an increase of passenger comfort, because the movements of the control cable of the flight controls is fast, so it can absorb all the absorb all the turbulence or sudden change of the aircraft movement faster compared to the conventional system. Then in terms of in the cockpit, easier interfacing to autopilot and other automatic flight control system, like I said previously, easy to integrate with several flight control system. Then for maintenance reductions, yes, of course, there's a lot of lot of works that need to be done on the conventional system. Now no more on the fly-by-wire system. Then reduction of airline pilot training costs, because most of the system is same, like example A320, A330, A340, even the A380, the cockpit layout is all same, because all the system is taken from the A320. So in case pilot need to upgrade from the small aircraft to the bigger aircraft, it's easier. And pilot also easy to understand the system. In the flight control computer, the computer continuously fly the aircraft. So all the movement of the flight controls is monitored. So there's no need for the pilot to do adjustment. And then lastly is also improve the economy in flight, because save weight and save maintenance costs. So there's no more need for the engineer or technician to replace the control cable, which is very costly. And the ground time for the aircraft during hangar check also can be minimized, because no need to inspect the whole control cable throughout the aircraft. Okay, that's it for the fly-by-wire system. So now most of the aircraft is using fly-by-wire system, which utilize a bundle of wires. So in the next future, what's the other technologies? Currently, from what I found in the internet, now there's a fly-by-wireless technology research, and also there's a fly-by-optic. That means from the computer to using a fly-by-wireless. That means from the computer to the actuator. Now there is no more cables, all done wirelessly. So maybe for the students in UTM, maybe can consider this topic for the research, whether it is suitable or not to be used on the aircraft. Another one is fly-by-optic. It means instead of using wire, but is using a fiber optic, using light as a transmission, data transmission. For info, now the only aircraft that using optic technology is a 777, but that is not for flight control operations. It's only for land communications in the aircraft. Okay, I think that's all for me. Any questions, Encik Dr. Nazri?
Okay. Any question from a student?
Assalamualaikum, Mr. Syarizal.
Waalaikumsalam.
I am Fauzi.
Okay.
I want to ask about the aircraft which use a conventional cable system. Is there any range of flight hour on when to do the inspection? As you said, the inspection is due by visually, so you need to open the component part of the aircraft, right? Like fuselage or wing.
Okay.
So yeah, that's I want to know also about the flight range or flight hour. Thank you.
Okay. Number one is flight range. Actually, it's not really give effect for on the flight range, whether using a conventional system or controllable or the fly-by-wire system, but it will cost a lot of money on the unnecessary weight. Means compare by the aircraft that using control cables and also by fly-by-wire, it will cost a lot more fuel on the conventional aircraft. For the range, it's not really affected, but it can be compensated by carry more fuel. Like a 747, very long, it's a long range aircraft. It's using cable, not using a fly-by-wire. So, in terms of range, not really affected, but it need to be compensated by carry more fuel compared to the fly-by-wire system aircraft. And number two, about the maintenance. Usually for the cable inspections, because sometimes it takes a longer time. So usually the inspections will be programmed to be carried out when aircraft go to hangar for heavy check. Basically, there are several types of inspections on the aircraft, level of inspections. One is line maintenance, like the aircraft during transits. Usually, we not carry out the detailed inspections on the control cable. But when the aircraft go to hangar for the C check or HMV or D check, then during that time, the engineers or technicians need to do inspections on the control cables.
Okay. Okay. Thank you, Fauzi. Anybody else want to ask question? Okay, maybe while waiting for others, let me ask one question. Mr. Syarizal, can you tell us about the workforce? I mean, how many person that require? For example, let pick up one example. For example, a 777 airplane, and they grounded for a few days, and then the airline asked to do whatever the MRO on the fly-by-wire system, and then how many person or how many personnel, technician or maybe licensed engineer that a company need to do this MRO on fly-by-wire system?
Okay, actually it's depend on what is the works requirement. Let's say the aircraft is grounded for a few days because of the unplanned issues on the aircraft. Let's say fly-by-wire have a problems. So not too many personnel required. Maybe there will be one engineer for mechanical side, like I'm on the mechanical, and one engineer for the avionic. Because fly-by-wire, actually the person who have most responsibility for the inspections is a avionic engineer. So under the engineer, maybe 2 or 3 technicians, depend on the what's the type of the problems. But let's say the aircraft goes to hangar for C check or for HMV, so there will be lot more engineer. So for one aircraft, they will divide it by several sections, and each sections will be have one engineer for the mechanical engineer. So total maybe around 7 to can say 7 or 10. 10 is for the aircraft, for the bigger aircraft lah. For small aircraft, maybe 5 to 7 engineers. Maybe for the avionic, maybe there are 2 engineers, and under us will be 5 or 6 group of technicians.
Okay, so we have the last 2 questions. Okay, so in the chat box, Mr. Shahrizal, if you open the chat box, so Leong Chi Hang asked a question. Good morning, Mr. Shahrizal. Can I know what is the role of LAE in maintenance of fly-by-wire system? Since there are no control cable, which part that you check?
Okay, for the work scope, because of the fly-by-wire system now consists of avionic parts and also mechanical parts. So in terms of mechanical parts, we will check on the control system, on the control surface, while the other system, like the computers, the wiring, all will be done by avionic engineers. But both of us can do testing. Let's say testing of functional checks from the cockpit. So let's say aircraft come to the hangar for check. So any of us, usually the mechanical engineers lah, we will do all the flight control tests. So if there's any problem, we will check from the computer which is the source of the problem. If the source is of the problem is from box or from the wiring, so we will communicate and liaise with the avionic engineer about the problem. But in case the problem is from mechanical side, let's say there's a hydraulic leak on the control surface, so there's a task for mechanical engineer.
Okay, so the last question from Oi. Okay, good morning, Mr. Shahrizal. May I know why only aileron has no mechanical backup like other control surface? Referring back to your slide 8 or 9. I don't know, Oi noticed that only aileron has no mechanical backup, whereas others got one.
Okay, actually in the video just now I mentioned that the backup for the aileron actually is covered by a rudder. In case of the aircraft total power failure, actually the pilot will not do much movement on the roll. It will more important the yawing of the aircraft. So because if the aircraft have no power but using roll, it is a bit dangerous, because usually when aircraft do roll, it will need to be assisted by the other system such as rudder. So it is better in case of the power failure for the fly-by-wire, pilot only control the rudder to change the aircraft heading instead of using aileron.
Okay, thank you. That's remind me a glider, because we noticed that many glider has only rudder and elevator and no aileron. Okay, so most of the maneuver can be performed by this rudder and elevator. Okay, so I think that's all for today. So thank you very much, Mr. Sharizal, for very informative talk and briefing, especially for our student. So even though it's only an introduction, but basically it helped us a lot, especially for our student, to understand this, because I confirm that this fly-by-wire technology is one of the important system in the aircraft, because it involved in navigation for the steering of the airplane and so on. Okay, so without this fly-by-wire technology, so the airplane has no ability to move all the control surfaces. Okay, without the control surfaces, then the airplane will fly without any direction or instruction or control by the pilot. Okay, so it's very important system in airplane. Okay, so I think that's all for today. Thank you very much, Dr. Sharizal, Mr. Sharizal, and hopefully that we can see you again in future.
Inshallah.
And thank you for the time that you spend with us this morning.
Okay, no problem, my friends. Anytime.
Okay. Okay, so that's all for today. I think I'm going to disconnect or close this conversation, and have a nice day to everyone.
Okay, stay safe, everybody.
Okay. Okay, thank you.
Thank you, doctor.
Okay, doctor. Okay, thank you.